So our first speaker is Eduardo Lazzarotti from Bentley Systems, and he's the Director of Product Management for Legion. And Eduardo is going to be sharing a case study of Waterloo Station and Bond Street. Eduardo's been with Bentley for 6 years through the Legion acquisition, and prior to that he was with Ramboll, where he managed business development in the UK and overseas. Key accounts for him at the time were Network Rail and London Underground. Eduardo holds a master's in economics and political science from the London School of Economics, as well as other degrees from ESPM in Brazil and Peking University. Welcome, Eduardo.
Well, thank you very much for the introduction, Phil, and thank you very much for everyone for joining us today. So let me share my screen. Let's see if it works well. So yes, so just a brief introduction to Bentley Systems. So we are around 4,000 software enthusiasts placed all over the world. We are originally from the US and Philadelphia, but we actually grew in many different geographies. Actually, I'm talking to you guys from London in the UK, where I have been for the past couple of years, working in rail and a few other infrastructure projects. So as mentioned before, I am the product management director for our buildings solutions inside of Bentley. So as I mentioned just earlier, we are passionate about software, but we are also passionate about infrastructure. So different types of infrastructure projects, all the way from railways and roads, down to factories and buildings and power plants, all the way from design through construction and to operation. So I manage our buildings applications, starting with our flagship product called Open Buildings Designer, but also with a few other applications. We will talk a little bit more today about Legion. There's our simulation application for people movement, and a little bit about the impact that that solution has had since the beginning of COVID, back at the beginning of the year, and all the social distancing requirements in some different types of buildings over time. So just a very brief overview of the biggest glimpse of the future for us at Bentley. We believe that our industry, the AST industry and the construction industry, are already going digital. So aligned, of course, with some of the projects that we have here in the UK with the Digitally Built Britain. But over time, over the past couple of decades since Bentley was created, we have seen this upgrade from desktop-based applications into servers, mobile, and then of course today a lot of the projects being cloud-based and collaboration happening as this presentation is happening right now. Exactly, almost in parallel to that, we have seen an improvement or an upgrade of the types of files and the types of methodologies that we have in terms of designing, building, and operating infrastructure. So we upgraded from 2D views of projects into 3D models. More recently, we added the fourth dimension of time into the project, so we can actually plan construction and delivery of that project, and then all the way down to 5D with cost and environmental impact. At the same time, the decisions and outcomes have changed. We moved from drawings and reports, so pretty much paper-based, into digital standards and processes. And nowadays we are migrating with this whole idea of going digital into data analysis and insight out of that data. So very brief introduction. I know there was another talk about digital twins before and the glimpse of the future, but just a very brief overview of what digital twins are. So they are a digital representation of a real life asset, and that asset can be pretty much anything. Of course, this whole trend of going digital, it's not new. It has happened already in the financial industry, in the manufacturing industry, and now we are seeing that actually being adopted by construction and by the AC industry. So what is that virtual representation? Well, we can go through many different applications. Here we are just seeing three very quickly. One of them is imagery analysis for remote inspection, for instance, of a bridge, where we can do the analysis of the digital reality of that bridge, and we can find cracks remotely in that specific asset. We also have the pedestrian simulation or the operation simulation of a station. That is the focus of the two case studies that I'll present today, and also the simulation of construction, so all the timing and the whole process of construction and delivery of a project. So as I mentioned before, a digital twin is actually a representation of a real asset, either during the planning or design or construction or later on into operation phase. And we see that the biggest value of that digital twin is actually using all that data about that asset to improve operation and deliver more out of it. So if we get just a very quick example here of a train station, let's say we have an issue with the canopies in the station that has been identified via cameras or IoT sensors or devices, we can very quickly access all the information about that asset. So all the maintenance records, inspection records, and we can push that information into operations. So we actually increase the reliability, we reduce the time to maintenance, and of course we maintain that asset open for longer, saving time and delivering a better service to the final users. Exactly the same way during the design and build phases, we can actually minimize rework, we can enable collaboration, we can enable engineers in different parts of the world to work in a project. And during the build phase, we can also save time, save money, and make sure it is being delivered right the first time. So a great example of a digital twin is High Speed 2 now in the UK. The plan there is to have a fully integrated and kind of like future case study digital twin before they go into construction, guaranteeing that that will be delivered in time, which is very important for such a large project. So overall, as I mentioned before, digital twin will leave all the way through the asset lifecycle from the project. So from very early days in planning through detailed design, construction, and then operation. But let's just take a look at some of the applications, and we'll focus here at the simulation of passenger movement with a very specific area that is actually inside of train stations. And for that, we'll be taking a look at two specific stations. One of them is Waterloo Station in London. It's operated by Network Rail. And it is the busiest station in the United Kingdom, also one of the busiest stations in the world, actually. So we have seen a huge increase in demand in that station in the 90s, from around 59 million passengers a year to just over 100 million passengers over the past couple of years. So it's a very central station. It has connections between London Underground, so all the underground, some of the underground lines in the city of London, but also all the kind of south of the UK trains coming into the city of London. So Monday to Friday, very busy, very crowded peak times, or at least out of social distancing and COVID situation. But then over the years, what we have seen over the past couple of decades is that a station that was designed and planned to look like this in the top right picture would sometimes look like this. So we'll see that very regularly in the newspapers, and that happens either because of disruptions, train cancellations, maintenance issues, or pretty much any other type of event that hasn't been planned or that has been planned for, but we don't necessarily have the solution for that yet. So one of the applications of digital twins, and in this particular case, Network Rail has been using Legion for more than 2 decades at the moment, and all their largest stations, not only in London, but throughout the UK, also use simulation for. It's actually to understand the operation of that asset. So here we see a run of the peak time operation of Waterloo Station, so 8 a.m. to 9 a.m. Every single dot that you see moving around the screen is a passenger, and we'll see all the different parts of that asset. So all the different platforms for the overground, all the stairs that connect to the underground, the concourse, the shops, the entrances and exits, taxi ranks, and all the different types of activities in space. And based on that base model, what Network Rail will do is actually test different scenarios. So what is the best timetable? What type of technology do I need to use? How long will people linger in my space? How many people will buy a coffee before they go into their train? And they can start making changes to the infrastructure based on those simulations, and also to the operation of that station. So where do I put my signs and my wayfinding structure? Or where do I position my staff? Or how do I test for evacuation in the case of an emergency situation, for instance? So another output of simulation is also heat maps. So here, actually, what we are seeing is just a heat map showing sustained crowding in specific parts of the station. So as I'm sure you can guess, the red is bad, and blue or green and yellow are actually slightly better. And that is based on a level of service that was researched by Fruin, an architectural researcher and professor back in the 70s, where he just defined the amount of space per person, all the way from free circulation in space down to complete breakdown. So the moment when you cannot just walk unimpeded throughout space and you start actually hitting and bumping into other people and you have to reduce your speed. So how does it look like for network rails specifically? Well, they actually took some pictures to show people what the different levels of service mean. And this is pretty much what informs the whole process of planning stations, of designing new stations, of refurbishing some of the existing stations, and decommissioning some of the other ones as well. So it goes all the way from level of service A. So you can see there's a little bit of a marking here just to show the amount of space per person. And it goes into B, C, and then we go into the more challenging in terms of operation levels, E and F. So in case of safety and security for the operation of network rail stations and Transport for London, as we'll talk a little bit later as well, levels of service E and F are the breakdown levels of service, where pretty much what they will do is they'll have to shut down operation, wait for people to dissipate and leave the station, and then reopen and set again the operation for that specific station. Of course, as we will take a look at the next case study, but also in this one, as these big stations are also nodes in a network, whenever we shut down one station, that will have big effects in the whole operation throughout the network. So as we move on into another case study, we'll take a look at Bond Street Station. It's a very central station, Zone 1 in London, operated by London Underground. There is part of Transport for London. It's pretty much the operator of all transport modes in the city of London, controlling traffic, cycle lanes, boats, and of course, trains. And that over the years has been investing quite a lot in public transport. So just a caveat here, we will talk a little bit about Bond Street Station, as we'll take a look at the challenge that they have, some of the things that they have done, and then we'll take a look at the life cycle of a digital twin in between. So not necessarily everything in the video has been done for this specific project, but it's pretty much an overview of what can be done and what is the methodology to be adopted, or that a lot of other users are actually adopting today to take a look at that specific type of asset. So as I mentioned before, Bond Street Station is very central. It's just close to pretty much everything, offices, but also touristic spots in London. It is also a junction between Jubilee Line and Central Line. So here we see the configuration of that station just a couple of years back, just before this project that we'll take a look at. And what is the biggest issue there is that they have seen a huge increase in demand over the past couple of decades, very similar to Waterloo and very similar to actually public transport throughout the city of London over the past couple of decades. And over the years, what we have seen is that we have been achieving the levels of service E and F, so close to breakdown, which is unsafe. Of course, many times they cannot stop trains there, which means overflowing passengers into other already busy stations. And then looking into the whole digital life cycle of that project, here we'll take a look at some of the steps that can be taken into that digital twin context. So the first part was taking the digital reality of that space through photogrammetry and point cloud data. We can go and create the whole mesh of reality, or the digital representation of that space. And then as we go into the design of that station, then we look through the different stages and steps of that design, from planning through conceptual design and detailed design. We'll take a look at some of the things that can be done, or in this case, as you can see in the video, that have already been done in the case of Bond Street Station as well. So as we go into detailed design, this is an imagery from our product called Open Building Station Designer. We can use digital components, like for instance, ticket gates, and very quickly we can do simulations to represent different options or alternatives of that design. That digital twin then later on can also be used for operations. So here very quickly we are looking at some examples of utilization of that model for operation during COVID. and all the social distancing requirements. So what we are seeing is all the dots moving around, as we saw before in the Waterloo case, but we are also seeing a circle around them. There is pretty much the either 1.5, or 2 meters distancing that we are requiring from different types of assets around the world. So that digital twin that we brought from planning and detailed design into operation, we can also use to test multiple variations and multiple scenarios in terms of operation. Exactly the same thing when we look at detailed design. We can use generative design as a very powerful tool to change very quickly or to test different variations of design in that specific space. So if we get here another example of social distancing, we are just placing some stickers that we have seen in many places around the world, showing the distancing that passengers have to be from each other while they are in the platform. And that can be done very, very quickly based on this baseline digital twin or based on this 3D model that we have as a representation of that space. Another type of simulation that can be done very quickly based on that model is actually the energy consumption of that space. That, of course, will take into consideration heat gain and loss, light incidents, and overall, what is the energy consumption profile of that space. So we can actually guarantee that that piece of infrastructure is going to be efficient, not only from a passenger movement perspective in terms of safety and comfort, but also in terms of consumption of energy and so on. As we move on from design into construction, that digital twin can also be used to plan every step of the way of the construction. So here we are just seeing another example in London of Battersea power station. And what we can see is day by day, all the different activities of construction that have been delivered in that specific project. So that, of course, can then be used for reducing risk, for saving time, for making right the first time, and for planning for different types of disruption during the construction process. And after we deliver a project, the whole idea of a digital twin is that it will live on for operations. So here we have another example of Microsoft's headquarters for Southeast Asia in Singapore, where we will see the digital representation of that building. So we have seen that there is the context of the city, there's the building itself, and then what we can do is we can connect that digital twin to IoT devices in that space. And then we can measure and very quickly visualize information regarding power consumption that then can later on also be used for simulation of energy consumption. We can understand usage of those spaces, so occupancy. We can understand distribution of space. We can understand safety and security measures like evacuation time or risk level in that specific building. And all that information, the whole idea is that as we are measuring it and as we are visualizing it as we operate, we can also gather that information and use it for simulation of future states. So as we have seen in the case of Waterloo Station before, as we learn with that information that we are gathering about that station, we can also simulate potential different futures or future scenarios for 10, 20, 30, 40 years in the future. Or even for situations like now, social distancing and COVID requirements. And we can test those potential future scenarios so we can learn with them and we can make the most out of this infrastructure. So one important information here is we are seeing it is all web-based. So one of the advantages of digital twins is that they are fully cloud-based. We work with our partner Microsoft, as you see the case that is actually Microsoft as well, with their Azure platform technology for cloud services. But then just coming back to the Bond Street Station case study, let's just take a look at what they have done in terms of simulation and in terms of adapting that station to the future. So as we see here, this is a run of the simulation for 2031. Peak time afternoon, so 4 p.m. to 5 p.m. And again, we will see all the different passengers moving around, going through the ticket gates, using the stairs and escalators, getting to their platforms or to their trains. And based on this simulation, actually what London Underground has done is they have decided what is the best operational plan for that station, what is the best evacuation plan for that station in the case of an emergency, what is the best timetable to avoid conflicts between the 3 lines that operate in that station now. So we have Central Line, Jubilee Line, and also
Eduardo, I hate
Elizabeth.
to do this to you, but
Sorry.
you're over time.
Oh, okay. So yeah, this is the end of the video and it's the end of the presentation anyway.
Hey, but can you just make the point that this is free until the end of September for people to use for COVID recovery?
Yes, absolutely. So we have the whole simulation platform open to new users should try it until the end of September. So please, if you are curious, do reach out and we'll be happy to present, talk to you and give you access to the tool.